તમે થોડોક અવાજ ઓછો કરજો એટલે કારણ કે આનું માઇક ખબર નથી મને કેવું પકડશો. Okay, let us start our basic structural analysis. First chapter, consistent deformation method. Those who were present yesterday, we had a short discussion about why this method is being used, right? If you see the syllabus of this subject, there are many chapters related to structural indeterminate structures, statically indeterminate structure. So as I have explained yesterday, best example of indeterminate structure, very simple, is a prop cantilever beam, a fixed beam, some continuous beam, many. You keep on adding the supports and the capital R value, which is reactions, gets increased, but your small r, which is what is small r? Number of equilibrium conditions doesn't increase. And in practical case, you will see most of the beams are this type, in which you have number of reactions more than number of unknown conditions. फटाफट आई जाओ તમે તો અડધો કલાકથી કોલેજમાં છો
સર સર જ નહીં આયા છે
કયા સર
મેરા ફોર્મ ભર
અરે એ હું એમ ઓકે અહીંયા અવાજ ના કરતા ફર્સ્ટ બેન ફાઇન સો let us take this example first. The reactions we have, tell me the reactions. Naik, which one?
horizontal vertical
Why do you always mention horizontal first?
vertical
No, what is the reason? Because it is not common. It will only occur if you have a horizontal force. Otherwise, it's not going to happen. And most of the cases, our loads are vertical. The most of the problems we have solved for SF diagram, PM diagram, we have seen the loads in this direction. Even if it is here, it is like this. So always, first is vertical, second is horizontal, because these two are forces, and the third reaction is moment. So this is suppose VA, HA, MA, and here VB and HB. If we make this as roller, this will be cancelled. Correct? Right. So let us say this is a roller for now. So that we have statically indeterminacy 1. Right? Number of reactions 1, 2, 3, 4. R is 4. Number of equilibrium condition 3. અહીંયા લખેલી છે એટલે જ મેં લાસ્ટ ટાઈમ લખેલી કારણ કે આવવાનું જ છે ફાઇનલ સેમિસ્ટર સુધી. So number of equilibrium conditions 3. So static indeterminacy is 1. It means that we need one more chocolate. We need one more chocolate to distribute among these 4 kids. True. So how to attain that additional chocolate? There are many methods, one of which is consistent deformation method, which means that if we take the analogy of chocolate, what are the probable solutions you think when you want an extra chocolate? Either you go to the shop to buy it, or you borrow from your friend, or you can make it by yourself, or you can just go somewhere and take it. There are many ways, right? Each way will give you additional chocolate which you can give to the children. Similarly, here This 1, 2, 3 and 4 are unknowns. Conditions are 3. It means that any one of these 4 unknowns is the children who doesn't get the chocolate. Anyone. If these 3 are given the chocolate, unanimal. If these 3 are given, unanimal. If these 3 are given, unanimal. समझाए छे? Right? I am just giving the analogy. So what to do? How to borrow from someone else or buy it from the store or make it? It means that we have to apply some another concept of structural engineering from which we can fetch another condition to make R as 4, small r. To make this equal, you have two ways, either reduce capital R or increase small r. Reducing capital R is, we can do that or not? No, why? Why we cannot increase capital R or decrease capital R? 3%. Can we decrease this? This relates to our end condition, support conditions, right? We cannot change our support condition because already that is decided. If we are designing a beam, it has been decided that we have to provide a fixed beam, or there is a beam which is fixed at this end, and the another end it is hinge support or roller support. It is fixed. We cannot change this condition. So changing capital R is not advisable, not practical, not required. करेक्ट? क्योंकि अगर ऐसा ही होता तो हम पूरे हमारी लाइफ टाइम में सिंपली सपोर्ट बीम then we would always design simply supported beam because it is very easy to analyze. You just take summation of m is equal to 0, calculate reactions, draw SNBM. Simple. But why it is not there, or it's only because that in practical you have to design lot many beams which are not simply supported. You cannot change them. So dealing with this, it means that you cannot reduce number of children who want chocolate. If there are 4 children, you cannot remove 1 children. It is the number is fixed 4. So what you have to do is provide additional chocolate. So you can deal with this, right? It means that if you are not able to decrease this, increase this. Correct? Simple logic છે એમાં કઈ મોટી વસ્તુ નથી. I am just explaining you the conceptual procedure involved in this method. તો તમને સમજવું ઈઝી પડશે કે કેમ આ બધી જફા છે. જેમ કે અહીંથી અંદમાન નિકોબાર જવું છે તમારે. You want to travel to Andaman Nicobar from Bharuch. You cannot take direct flight. Why? Because there is no direct flight. एयरपोर्ट नहीं है वो नेक्स्ट रीजन है क्योंकि वडोदरा में एयरपोर्ट है लेकिन डायरेक्ट फ्लाइट नहीं है. So you don't have a direct flight. So what you have to do? You go to the nearby city which has the flight for Andaman Nicobar. Say for example, nearby airports are Vadodara, Surat, Ahmedabad, Mumbai. So you search कि आचारमाथी पोर्ट ब्लेयर की फ्लाइट क्या है? And search में आवे कि no direct flights to Port Blair, Andaman. Then you find out कि okay तो अजी नजीकનું કેવું છે એરપોર્ટ જ્યાં સુધી ફ્લાઇટ જાય છે? So you get the answer Kolkata, Chennai, Vizag, 3-4 airports through which up to which you can go in flight. And then what to do? So you go to Chennai and then find out okay now I want to go Port Blair. What are the possible ways? Easiest way which takes too much time is by ship. And at Chennai you get to know that okay Chennai Port Blair direct flights are available. So you go to Chennai and then you have to take flight for Port Blair. It means that if you know that you want to reach Port Blair, you can find out ways. If you don't know that you want to reach to portrait, it will be difficult to find out ways because you don't know the concept for which you are finding the airports or locations. Similarly, here it should be clear in your mind that I have to increase R. Then and then mathematically this becomes 4, this becomes 4, and we can solve these 4 unknowns. Number of unknowns equals to number of conditions. Then and then mathematically you can solve any equations. This is very basic, we have learned in school. If capital R is greater than small r, you cannot solve it. Any one of the reaction will be unknown. Right? So to analyze, we must find out reactions. Then and then we can go for shear force and bending moment. So small r 3, so 3 conditions you can already have. You will put summation of forces. Okay, F na form. Okay. Summation of forces in x direction 0. You will get some equation. HA equals to 0. Whatever. If there are horizontal forces, you will get some equation. You put summation Fy equals to 0. You have some load. You will get the equation. You put summation M, suppose for is 0, you will get some equation. So 3 equations you got. This will be in terms of HA, Phalana Digna, HY, Phalana Digna. But you won't be able to solve it. Because in each equation there will be 4 children. Right, so how to generate this additional one? It means that you will have to borrow additional concept other than equilibrium. Till now, you were having 3 chocolates, which was given by you from the equilibrium equation. Equilibrium is a concept that we will remain in equilibrium in moment, in forces in x direction, forces in y direction, right? That was the concept through which we were getting these 3 equations, which is these 3. Now we need additional equation. It means that we need additional concept. સમજાય છે હું શું કહું છું? શું સમજાય? ના, એટલા માટે હું મારે રિપીટ કરવું પડે છે. હું જ્યારે જાતે વિડિયો બનાવતો હતો ત્યારે પણ મને એવું થતું હતું, કારણ કે મને અનુભવ તમારો છે, એટલે મારે એકની એક વસ્તુ બહુ વાર રિપીટ કરવી પડે તો જ તમને મગજમાં ઉતરે છે એવું મને લાગે છે. અને એવું થાય છે. કેમ કે અત્યારે આ બોલી ગયો, મેં 2 વાર રિપીટ કર્યું, પણ આને પૂછ્યું તો નથી કહ્યું. એટલે આ બધા સબ્જેક્ટ અઘરા છે, ધ્યાન અહીંયા જ રાખો. And at least try to be mentally with my pace. Otherwise it will be difficult. તમને થશે બહુ સરસ લેક્ચર થયો, મને થશે લેક્ચર પતી ગયો, આવડી ગયું. કંઈ નહીં આવડે. પ્રોબ્લેમ્સ તમને આવડી જશે, સોલ્યુશન આવડી જશે, બુકમાંથી ગોખણી કરી નાખશો, એક્ઝામમાં માર્ક આવી જશે. નહીં વાયવામાં આવડે, નહીં ટ્યુટોરિયલમાં આવડે, નહીં એક્ચ્યુઅલ તમને આવડે. એનો મતલબ નથી ને ખાલી ટાઈમ પાસ કરવાનો. ધ્યાન રાખજો. Once again I am reiterating that this additional equation, if you need to apply some additional concept other than equilibrium, which is present in the beam. It means that the 4th chocolate is hidden somewhere. Now you have found out that I don't need to go to the store, I don't need to make it, I don't need to borrow from someone. It is hidden somewhere in the room. That clue is given, that the chocolate is in the room. So what now you will do? Find out the chocolate. So there is additional concept hidden in this beam, which I will explain. Okay. Imagine I remove this support. For now, I remove that support. What will the structure become? Statically determinate. Suppose, say for example, load is also given. So we apply P load. This is A. This has 3 reactions, which can be easily solved by equilibrium condition. Right? How this beam will bend? How this beam will bend? True? Everyone Understand this reflected shape? Now, you know that you have removed the support in calculation. Now you have to put it back because in actual beam the support is there. समझ में आ रहा है? आपने अपनी सुविधा के लिए सपोर्ट को निकाल दिया फॉर मैथमेटिकल कैलकुलेशन, आपने सपोर्ट को निकाल दिया, कैपिटल आर स्मॉल आर सेम कर दिया। अब एक्चुअल बीम में तो वो सपोर्ट है तो उसको वापस रखना पड़ेगा। अब जैसे भी रखते हैं तो वापस इंडिटरमिनेट हो जाता है। इसका मतलब कि आप ये लोड की वजह से जो भी डिटरमिनेट स्ट्रक्चर बन रहा है which is called as redundant structure. Why? Because one redundant was removed to make this structure determinate. Actual structure is not like this. Actual structure is still this. But you have removed this VB to make it determinate so that you can solve it. Now again put this VB back. It means that again there has to be a structure in which you are putting VB back. VB is what? The reaction. Say for example it is unit right now, unit load. So you are putting a unit load here. तो ये जितना बैंड हुआ था उसको वापस उसकी जगह पे लाना तभी ये आएगा VB. It means that by removing the VB you got the deflected shape. Now again pushing VB, again you are giving VB as a react. VB is a reaction, but in the same direction you are doing what VB is doing actually in actual structure. What VB is doing, not allowing this point to go down. तो आपने हटा दिया तो पॉइंट नीचे जाएगा। अब आपको VB का काम करना पड़ेगा। जो VB कर रहा है तो वो क्या करेंगे आप? You will apply load in this direction so that again this point comes here. तो इसका deflected shape क्या होगा? It means that you know in this structure that deflection of this point is
0.
True? This point in structure has correct? It means that when you are removing it, whatever effect you are getting, you have to nullify that effect. Understand? So you remove the support, calculate this delta 1. True? Now you put load, unit value. So you are putting unit value. You know the value of load. You cannot put VB because it is unknown. So you put unit value, the value which you know, get, and use the hidden concept that delta 1 plus delta B should be 0. So you found out the hidden chocolate. So this is the procedural profile of this method. That is the reason it is called, because it relates to the deformation of beam. એટલા માટે આ જે beam છે એમાં ખાલી આટલું જ given છે એવું નથી. There are many other things which are hidden. સમજાય છે? તારું નામ શું ભૂલી ગયો? शीतल. समझाए? यहाँ तक जितना भी मैंने एक्सप्लेन किया उसमें कुछ भी डाउट हो ना समझ मुझे बताइए, तो ही मतलब वापस रिपीट करता हूँ. थिंक ऑफ इट. જેને ખરેખર ઉપરથી જવું હોય મને ફ્રેન્કલી હાથ ઊંચો કરીને કહી દો. આઈ એમ નોટ ગોઈંગ ટુ સ્કોલ્ડ, બટ મને ખબર પડશે કે કઈ જ નથી ખબર પડી, then I have to change my way of explanation. બટ આ વસ્તુ ખબર પડવી જ જોઈએ જેટલા પ્રેઝન્ટ છે ત્યારે. જાગે છો? કેમ છે તે કામને પાગલ થઈને બેઠા છો? હા, બોલો.
ડેલ્ટા ટુ છે જેમાં આપણે વીબી એડ કર્યું
થોડું જોરથી બોલો.
રિએક્શન એડ કર્યું આપણે
રિએક્શન નથી એડ કર્યું. રિએક્શનની ડાયરેક્શનમાં યુનિટ લોડ એપ્લાય કર્યો છે.
સોરી પણ આપણે પહેલા બધું ને રિમૂવ કર્યું એટલે આપણે રિફ્લેક્શન નીચે થયું આપણે એડ કર્યું રિફ્લેક્શન ઉપર
કારણ કે હું રિએક્શનની ડાયરેક્શનમાં યુનિટ લોડને એડ કરું છું.
બટ સર શું પોસિબિલિટી છે કે આપણે એડ કર્યું તે એક્ઝેક્ટ વીબી જેટલું થયું?
અરે બીડી તો ક્યાં ખબર છે?
સર તો આપણે ડેલ્ટા આઉટલેટ બરાબર 0 કરીએ તો આપણે વીબી મળશે, ડેલ્ટા 2 મળશે.
ના, ડેલ્ટા નું થોડો મળશે, બીડી મળશે. આ તમે કર્યું, આનો ડેલ્ટા આવ્યું, આ જે ડેલ્ટા 1 છે એના ઇક્વેશનમાં p હશે, l હશે, e i સમથિંગ હશે, કંઈક હશે. આ તમે ઇક્વેશન એડ કર્યું, એના ઇક્વેશનમાં p હશે, l હશે, e i હશે. p તમારો શું છે અહીંયા 1 છે, એટલે આ 1 હશે. l e i ના ફોર્મમાં ઇક્વેશન હશે. ડેલ્ટા 1 અને ડેલ્ટા 2 એડ કરો. This will be having unknown values. This will be having unknown values. Delta 1 plus delta 2 equals to 0 will give you additional equation number 4. You have this equation number 1, number 2, number 3 and 4. So now you have 4 equations and 4 unknowns. You are finding out additional equation which is the chocolate in our analogy. जो हिडन चॉकलेट ढूंढनी है वो हिडन इक्वेशन ढूंढना है, तभी स्मॉल r का वैल्यू 3 + 1 होगा. नंबर ऑफ अवेलेबल कंडीशन और अवेलेबल इक्वेशन. So 3 equation we are getting from our regular customer chocolate who gives us chocolate equilibrium condition, and this additional hidden we have found out from delta 1 plus delta 2 equals to 0. Suppose તમને થાય કે આને જ કેમ તમે તરીનો બકરો બનાવ્યો? Why did you remove this support? उसकी क्या गलती थी? वो बेचारा बहुत अच्छा था, उसके पैरों में स्केट्स लगे थे, इधर उधर मूव कर रहा था, बहुत ही सपोर्टिव सपोर्ट था. आपने सपोर्टिव सपोर्ट को क्यों निकाला? तूफानी सपोर्ट को निकालो. You can do that. Remove suppose PA or remove suppose fixity, remove MA. MA को रिमूव कर दिया तो रिडंडेंट स्ट्रक्चर क्या बन गया? ये तो अपना भाई है, सिंपली सपोर्ट बन गया. अब क्या होगा? लोड की वजह से रिफ्लेक्शन आएगा. आपने रिमूव क्या किया है? MA. So MA relates to slope, force relates to deflection and moment relates to slope, right? तो इसका डिफ्लेक्शन क्या होगा? करेक्ट. नाउ एक्चुअल बीम में क्या है? MN in this direction, right? So you give unit moment to push this beam back to its original position, right? Calculate theta. So in this case there was some theta 1. In this case calculate theta 2. Theta 1 plus theta 2 equals to 0 because fixity पे theta नहीं होगा. इसका एक्चुअल डिफ्लेक्शन ऐसा है. There is no theta here, right? So you can use this method also, whichever is convenient. So from any 4 you can remove any one if your SI is 1 in this problem. If SI is 2, you have to do the same procedure for 2 redundancies. If SI is 3, you have to find 3 additional hidden chocolates. If SI is 25, you have to find out 25 hidden chocolates. But એટલું બધું hand calculation થી possible નથી. એના માટે softwares and matrix methods. So in this chapter, mostly you will have SI 1 or at least 2, not more than 2. so that you can solve the problem. It becomes little easier and less time consuming. Clear? I don't want to start problem today. I just want to be assured that this method and this procedure is well digested in your brain. How to calculate delta 1? In last semester subject theory of structures, we had a chapter for deflections. What are the methods to calculate deflections? एक પછી અદનાન
conjugate beam method,
conjugate beam method પછી Macaulay's method પછી moment area method. Correct? એનો મતલબ કે in this step we will require our knowledge of theory of structure to calculate delta 1. If you want to use it, moment area method. If it is comfortable to use moment area method, calculate delta 1 delta 2. If you are good with conjugate beam, use conjugate beam. If you are good with energy principle, use energy principle, strain energy. If you are good with Macaulay's method, Castiglione जो ये semester में. So any method to calculate deflection can be used in this consistent deformation method. Clear? I assume that mostly you will be using moment area or conjugate beam. Two comfortable methods. याद છે તમને moment area method? અને તમે self study માં કર્યું. याद છે moment area method? M upon E diagram. Okay. While doing the example, I will explain. Moment area કેમ કે last semester માં તમે self study માં વાંચ્યું તું નહોતું વાંચ્યું જવા દો. M upon E diagram ખબર છે? તમે પેપર કેવી રીતે આપ્યું? છોડી દીધું તે પ્રશ્ન? હા? એટલે ઓપ્શન એવો હતો સોલ્વ બાય એની મેથડ એવું હતું એક્ઝામ. So you have not solved any problem of deflection in examination. Moment area Okay. Suppose this is the beam. હું just recall કરાવું છું કદાચ કોઈ સેલ્ફ સ્ટડી માં કર્યું હોય actual problem કરીશું ત્યારે હું explain કરીશ તમને. I am just giving you a brief about moment area method. Right? As the name suggests, moment area. It means that we have to take moment of area. Right? What is moment? Something into perpendicular distance. So if it is moment of area, it is area into perpendicular distance. If it is moment of force, which is bending moment, which is force into perpendicular distance. Clear? So whenever we see the word moment, it means that the quantity multiplied with perpendicular distance. So if it is moment area, it is area into perpendicular distance. Area of moment or moment of area. Clear, sir? Okay. So what we do is simply we draw the bending moment diagram of this beam. It will be something like that. Let us not go into the values. कुछ आएगा value PL over EI something. 2PL, 3PL, 5PL, whatever it is. जो भी याद नहीं है वो value आएगा. This is the bending moment diagram of this beam. Correct? Now, what is moment area method is that on an imaginary beam you apply this beam bending moment diagram, which is called M upon EI diagram, as load. I will explain in detail when we go for this. Giving you shortly, this is the area, right? You can calculate the area. What will be the moment? There will be some CG here, 2 by 3 distance from here. So this, because you want deflection here, right? So moment will be from the point where which you need deflection. So this distance into area will give you delta 1. હમણાં યાદ ના કરો, કન્ફ્યુઝ ના કરો, ખાલી સાંભળી લો હું જે કહું છું તે. This area જે પણ વેલ્યુ આવે તે it will be in terms of P L E I into this perpendicular distance. It should be the moment area, right? That will be deflection, delta 1. Here delta 1, this delta. Again you are giving force, you are having a different beam in which you are giving this force, right? Conjugate beam માં તમને યાદ છે fixed support free થઈ જાય. So okay, so this becomes a conjugate, suppose a conjugate beam હોય so this becomes free, this becomes free, fixed. Similarly this becomes free, this becomes free, this becomes easy. તમને ખબર જ છે. And when you apply this force, what will be the moment diagram? Something like this. This will give you, so this entire area, CG of that area into this perpendicular distance will give you delta 2. This will be minus, this will be plus. As it is seen that in this diagram, loadings are downward. So this will create negative bending moment diagram as per the sign convention. And here the loadings are in opposite direction. So it will create opposite bending moment diagram naturally according to sign convention. So this minus delta 1 plus delta 2 0. This additional condition was the hidden gem, hidden chocolate. Right? Using this, you can easily get values which are the unknowns. So either you use conjugate beam moment area or both to calculate deflections. And then this is the method used to solve. मैं जो सिलेबस में चैप्टर ना वो कलाक नहीं आता કેટલા છે 5 કે 6 5 છે એમાં એક કાલે પતિ એક આજે પતિ ગયો રહ્યા કેટલા 3 અને બે બીમ નો ટાઈપ છે એક પ્રોપ કેન્ટિલીવર છે અને એક ફિક્સ બીમ છે. ફિક્સ બીમ માં શું થશે? If the beam is fixed, કેટલી એડિશનલ હિડન ચોકલેટ શોધવાની છે? 3 ત્રણ વાળા જપા કરવાની. એમાં એક ફાયદો છે કે જે 6 છોકરાઓ છે ચોકલેટ માંગનારા એમાંના 2 માંગા છે. આમાં કેપિટલ આર શું છે? 6 છે. 1 2 3 1 2 3. So you have 6 children among which you have to distribute 3 chocolates. Now you found that among those 6, 2 children are having fever. Chocolate should not be given. It means that in beam, suppose there is no horizontal load. There is no horizontal load. No horizontal reaction. So your R reduced to 4. Additional condition and small r is? Small r is? Small r is? Small r is? 2. When you don't have horizontal force, you don't have horizontal reaction, so you can't use horizontal equilibrium condition. So R is, it means that now you need only 2 hidden chocolates, which was earlier, if this was the case 6 and 3, then you need 3. if there is no horizontal force, which is in most cases, there are hardly horizontal forces on beam, except for industrial structures. When we are designing industrial structures, we may get horizontal forces because in industry there are many components, pipelines, other moving parts, other elements are on the beam. So you may have, imagine a beam in a industrial shade. This is a beam and some angular beam is also going, which is supported on some another component. And from that component to this beam, they have some angular component, which will transfer the load of that component to this beam angularly. It could have been kept like this, but there is some pipeline going from here. So they have kept like this, so that a pipeline can go and the reaction can come. So in these cases, such cases, which is complex geometry, complex structures, you will have horizontal forces. But in normal our frame structures, residential buildings, commercial buildings, multi-story structures, in beams, hardly you have horizontal forces. Right? So capital R becomes 4, small r becomes 2. So you have to find out only 2 additional hidden chocolates. So what we will do next in next class is we will solve this problem with some values, L values, load values, everything. Then we'll solve another problem of prop cantilever in which this is not roller. And this is not roller, you have 2 redundants. So this R becomes, small r becomes C, 3. So you need 2 hidden chocolates. And one problem of fixed beam we will solve. So mainly 3 problems are to be completed in this chapter. In next 3 hours. Not this right now 3 hours, next 3 lectures. સમજાય છે? એટલે એટલું યાદ રાખજો કે એક ક્લાસમાં હું પ્રોસિજર નહીં એક્સપ્લેન કરું હવે. ત્યારે મને આના ડાઉટ ના પૂછતા કે સર આ ડેલ્ટા 1 કેમ લીધું, આને જ કેમ યુનિટ લોડ આપો છો. I have explained enough. Whatever redundant you are removing, you have to provide whatever it was doing, you do it with unity. This is the procedure, the main concept. Whatever the redundant was doing, you do it with unity. If this was providing, if this support was resisting the deflection, provide it with unity. If this was resisting moment, provide it with unity. Clear? ये जो कर रहा था वो आपको करना है additionally with unity. That is the concept. To get deflection 0 or theta 0. If it is about moment, we have to deal with theta. If it is about force, we have to deal with. Okay? Why force is related to delta and moment is related to theta? This we are talking about deflections, right? That is the reason this method is not called consistent deflection method. It is deformation means theta delta. Deflection is delta. Theta is slope. Wrong? जागृति कब से? सुबह से, शुरू से, मतलब उसके पहले नहीं जागृति. So consistent deformation related to theta and delta. आप मुझे बताइए, अगर फोर्स लग रहा है तो हम डिफ्लेक्शन ले रहे हैं, और अगर मोमेंट लग रहा है तो थीटा क्यों ले रहे हैं? इसमें ये क्यों नहीं ले रहे? और why this doesn't relate to this and this doesn't relate to this? कौन बनाना जवाब आपसे? This common sense. समझा जी क्वेश्चन? When we say that force refers to delta, or force will create delta, deflection, and moment will create rotation, theta. Why do we say that? Why? किसने बोला? Why doesn't force relate to theta and moment relates to delta?
एंगल में लगा
कौन सा एंगल?
इसलिए इसको थीटा बोलते
इस
हैं एंगल में लगा
मुझे समझ में नहीं आया तुम्हारा एक्सप्लेनेशन.
सर फोर्सेस तो मतलब वर्टिकल लागे हॉरिझॉन्टल लागे तेમાં थीटा होती बट मोमेंट सर ते रोटेशन આવે so તેમાં થીટા જનરેટ થાય તો થીટા રિલેટેડ
એ પેલામાં થીટા ના જનરેટ થાય.
So the load दे रिफ्लेक्शन होगा ना और मोमेंट में मतलब पूरा मोमेंट कर रहा है तो फिर इसमें थीटा
सही है. मैंने बोला कॉमन सेंस हमको पता ही है लेकिन पता है फिर भी ढूंढना है. कई चीज हम आसानी से एक्सेप्ट कर लेते हैं, कई चीजें हम आसानी से एक्सेप्ट कर लेते हैं, which becomes belief. Unless you cross check your belief, it becomes truth. मैंने बोला कि force relates to delta, moment relates to theta. सबने बोला yes, that was in your belief कि मैं बोल रहा हूँ तो सही होगा. If you rethink कि ये सही है गलत है क्यों है, then that belief becomes the concept which you now know क्यों होगा. વધુ છે સવાલ? શું કરું? ઓકે, અહીં ઊભો રહે. આ શું આપું છું? ઊભો રહે છે? પગથી ના ઊભો છે તું. સામે છે. What I mean? So what is observed? Delta. Delta is what? Deflection. So he is moving. Right? એટલો બધો સ્ટીફ ના રહે ને? થોડો તો લિબરલ. I am giving force. What I am saying?
रिफ्लेक्शन
Delta. Only delta. Is there any slope here? Slope is here. અહીંયા છે slope. જેમ કે તમે અહીંયા ડેલ્ટા આપો તો આ બધે સ્લોપ આવે છે ફોર્સ આપવાથી, પણ અહીંયા તો ડિફ્લેક્શન જ છે. What you are observing is, so giving this force you observe delta, but when I am giving moment કેવી રીતે મૂવમેન્ટ ના હાથ મારે એના કરવો પડશે. I have to give moment here, right? When I am giving moment, suppose આ બીમ છે અને હું આ સેમ કેસ આપણે કરીએ. when I am giving, હવે આ હાથ છે ને સ્ટીફ રાખજે, કાયદા કરો હાથ છે ને એ આ બીમ છે, સમજી ગયો ને? તારું નામ કૃષ્ણ, તારું નામ બીમ છે. Now when there is, this is load condition, right? This load is given, this beam will deflect according to this shape. Now you are giving additional point force. So what you are observing? This deflection. Certainly the beam has different slope also, but at the point at which you are targeting is you are observing deflection. So it means that by giving force, what you are trying to do is, what you are trying to execute is move his hand from this position to this position. That's what you are trying to do by giving force. If I don't tell you that don't give force, if I tell you that મારે આનો હાથ અહીંયાથી અહીંયા લઈ જવો છે, તમે શું કરશો? Easy concept that you apply the force, it will go here. True? Now, what about moment? If I apply moment here, you will see that this hand doesn't go up or down. It means that deflect delta is not in picture. But what is in picture? So this point at the very end of his hand, if you are giving force, that point is going up and down. At the same point you are giving moment, it is rotating. That is the concept. So it is common sense. પછી common sense તમે લાંબા લાંબા વાક્યમાં લખો તો તમને માર્ક મળે, પણ કન્સેપ્ટ સમજ્યા વગર લખો તો માર્ક એટલા ના મળે. હવે તારું નામ? that is the reason that when we are talking about deflection, we have to generate force. When we are talking about theta, we have to deal with moments. આ ડિફ્લેક્શન નું ચેપ્ટર લાસ્ટ યર નહોતું તો એટલા માટે આ વસ્તુ રહી ગઈ. ઓકે, સો ગુડ ફોર નાઉ. આઈ હોપ એવરીથિંગ ઇઝ અન્ડરસ્ટુડ, એટ લીસ્ટ ફોર નાઉ. તમે લખ્યું છે નોટમાં નહીં કે હું वीडियो नहीं आपू तो अगर मैं देखूंगा और मुझे लगा कि तो मैंने बहुत ही लोचा मारा है, ठीक से बोला नहीं है, कंसेप्ट गलत समझा नहीं है, तो मैं एडिट कर दूंगा.
क्या देने के बाद
भी डिलीट करूंगा तो चला जाएगा. यूट्यूब है, ये यूट्यूब है.
अच्छा यूट्यूब से डायरेक्ट
हाँ डायरेक्ट लाइव है अभी.
सेव होता है ना सर.
ठीक है, मैं अगर ठीक होगा तो शेयर कर दूंगा, बट आई वांट यू टू रिफर इट. अगर ये नहीं हुआ अभी से नेक्स्ट क्लास में मैं जो कर रहा हूँ यहाँ पे गड़बड़ी, वो सब नोट में डाउन करो, नोट में लिखो, क्योंकि ये अभी आपको विजुअली याद है. या तो फोटो खींच लो, मुझे कोई दिक्कत नहीं. आई जस्ट वांट यू टू विजुअली रिमेंबर दिस लेक्चर इन योर मेमोरी, कि इसमें से एटलीस्ट 2 बातें तो याद आएगी. एटलीस्ट 2 बातें याद रहेगी लेक्चर्स में. अगर कुछ ही रिकॉर्ड नहीं रखा, जैसे हम घूमने गए केरला, एक भी फोटो नहीं खींचा, 1 साल 2 साल 3 साल 4 साल 5 साल, ठीक है, 10 साल के बाद हार्डली 1 या 2 जगह आपको याद आएगी दिमाग में. लेकिन अगर फोटो खींचे हैं 10 साल के बाद एल्बम निकाला, पूरी केरला की ट्रिप याद आ जाती है. क्यों? बिकॉज इट वाज हिडन इन योर ब्रेन. इट वाज नॉट एबल, यू वर नॉट एबल टू फेच इट. The photographs help you to fetch it because we have photographic memory. Similarly, આનો ફોટો લઈ લો, તમે નોંધી લો, કઈ કરી લો, પણ try to recall the lecture. કે ઓકે આનો consistent deformation નો ફર્સ્ટ લેક્ચર હતો, એમાં આપણે એના કન્સેપ્ટ સમજ્યા. Then and then it will be easier for you also. તમારો ટાઈમ ઓછો બગડશે. એક્ઝામ વખતે તૈયારી કરવામાં, ટ્યુટોરિયલ સોલ્વ કરવામાં કોપી નહીં કરવા પડે. નહીં તો તમે બધા કોપી જ કરશો, कॉपी ना मार्क आपू छो तने लोकोने, તમે બી ખુશ, હું બી ખુશ, તો તમને આવડશે નહીં. Okay, so we conclude for today's lecture. In next class we will solve this problem with roller, without roller, and in the next class this thing and the chapter will be done, so that we can move to next chapter, which is very important, slope and deflection methods and moment distribution method, જે મેં કાલે વાત કરી હતી તમને. તમે કશે બી જશો, આગળ માસ્ટર્સમાં જશો કે જોબમાં જશો, મોમેન્ટ ડિસ્ટ્રીબ્યુશન મેથડ, સ્લોપ ડિફ્લેક્શન હજી નહીં હોય યાદ તો ચાલશે, પણ મોમેન્ટ ડિસ્ટ્રીબ્યુશન એવી છે કે જે બધાને ખબર હોવી જોઈએ. ઇટ ઇઝ ધેટ બેઝિક. વી વિલ ડુ ઇન નેક્સ્ટ ક્લાસ. ઓકે, બંધ કરું.